और ना Good morning, learners and viewers. Welcome to the session of Management Information Systems, MMPO 004. Today, we will start with Block 3, that is Relational Database Management System, and in short, we call it as RDBMS. We'll start with Unit 7, that is related to organizing data. Data organization is the way to arrange raw data in an understandable order. Graphical representation, classification, and arranging of data are the parts of organizing data. Data organization helps in reading the data. We can easily work on organized data. Organized data determines the cause of problems in the organization. Data is knowledge in today's world. Good data provides helps in making informed decisions in the organization. And data allows the happening visible, organized. Data increases the efficiency of the work and the employees. It is right. Organizing data is essential for making informed decisions in an organization. By arranging and classifying data in a logical and understandable way, it becomes easier to analyze and interpret it. Graphical representation of data helps in understanding complex patterns and trends and can be effective way to communicate findings to others. Understanding the nature of data is important in order to properly interpret it and analyze it. This includes understanding the different types of data. The data can be numerical, categorical, ordinal, etc., and the various measures used to describe and summarize it, such as mean, median, mode, standard deviation, etc. Processing raw data. This involves transforming it into a format that is more easily analyzed and visualized, such as using spreadsheet softwares to organize and prepare summary statistics that is available in Excel software. Graphical representation of data is an effective way to visually communicate patterns and relationship within the data using charts such as histograms, box and whisker plots, funnel charts, to name a few. And some of them we will discuss in our discussion today. Classifying data involves grouping it into categories or classes based on relevant criteria in order to better understand and analyze it. We'll start with what are the different types of data. Data collection requires processing and identification of correct data. Accurate and processed data is used in research processes. For accurate decision making in the organization, perfect plan of data processing is needed. Data collection is a crucial step in the research process and it involves the identification and processing of relevant data. The accuracy of data is important for reliable research results and informed decision making in an organization. Data processing involves several steps, including identification, coding, comparison, and preparation of charts, among others. Proper data processing ensures that data is organized, structured, and analyzed in a meaningful way. Data can come in various forms and formats such as numerical, text, audio, visual, etc. The use of appropriate formats involves data management and facilitates data reuse. Data processing contains identification, coding, comparison, and preparation of charts. Quantitative data. Quantitative data can be expressed as a number or can be quantified. It can be measured by numerical variables. Height in feet and age in years are the examples of quantitative data. Quantitative data is used when a researcher needs to quantify a problem and answers questions like what and how many. That means related to some numbers. For example, how many customers bought a certain item in context of shopping, how much horsepower a car has, etc. Quantitative data is something that can be counted in definite units and numbers. This data is made up of numerical values and has numerical properties and can easily undergo numerical operations like addition, subtraction, multiplications. Quantitative data can be measured and expressed numerically, and it is used to answer questions related to quantities and amounts. Quantitative data, such as counts, measurement, or rating, it is used in such a way how many customers visited the stores today, or what is the average age of employees in the company. One of the advantage of quantitative data is that it can be analyzed and manipulated using mathematical techniques such as statistical analysis or mathematical modeling. Quantitative data can be collected through various methods, including surveys, experiments, and direct observations. Quantitative data is an important type of data in many fields, including science, economics, business, and it is used to support evidence-based decision making and problem solving. Then comes qualitative data. Qualitative data can not be expressed as a number and it cannot be measured. This consists of words, pictures, and symbols, but numbers are not used anywhere. It is also called categorical data because the information can be sorted by category. Qualitative data does not include numbers in its definition or traits, whereas quantitative data is all about numbers. The cake is orange, blue, and black in color, and females have brown, black, blonde, and red hairs are the examples of. Qualitative data is important in determining the particular traits or characteristics. It allows the statistician or the researcher to follow parameters through which a large data set can be observed. Qualitative data provides the means by which observers can enumerate the world around them. Nominal data. It is used just for labeling variables without any type of quantitative value. The name nominal comes from the Latin word nomen, which means name. The nominal data just names a thing without applying it to order. Actually, the nominal data could just be called labels, that is, genders, male or female, hair color, blonde, brown, brunette, red, etc. Marital status, married, single, widowed are the examples of nominal data. Eye color is a nominal variable having a few categories such as blue, green, brown, and there is no way to order these categories from highest to lowest. Ordinal data. This shows where a number is in order. This is the crucial difference from the nominal type of data. Ordinal data is the data which is placed into some kind of order by their position in a scale. Ordinal data may indicate superiority. One cannot do major arithmetic with ordinal numbers because they only show the sequence. Ordinal variables are considered as in between qualitative and quantitative variables. Or we can say that ordinal data is qualitative data for which the values are ordered. Interval data. Interval data is a type of quantitative data that has numerical values that are spaced at uniform intervals. This means that the difference between the two adjacent values on the scale is equal, and each value represents an equal interval of the underlying attribute being measured. This is commonly used to measure things like temperature, time, or calendar dates, where there is a fixed interval between any two values of the scale. Unlike nominal or ordinal data, interval data can be added, subtracted, or averaged, and can be analyzed using a wide range of statistical techniques, including measure of central tendency, that is mean, mode, median, and measures of dispersion, such as variance, standard deviation. Discrete data. Discrete data is a count that involves only integers. The discrete values cannot be subdivided into parts. For example, the number of children in a class is discrete data. Another example of discrete data are the number of students in a class, number of workers in a company, number of homes runs in a baseball game, and number of test questions you answered correctly. Then comes continuous data. It is an information that could be meaningfully divided into finer levels. It can be measured on a scale or continuum and can have almost any numerical value. For example, you may measure your height at various very precise scales, that is, it can be meters, centimeters, millimeters, feet, etc. A good rate value rule for defining if a data is continuous or discrete is that if the point of measurement can be reduced to in half and still make sense, the data is continuous. Example of continuous data are the amount of time required to complete a project, the height of children, the square footage of a two-bedroom house, the speed of car. These are the examples of continuous data. Then comes data processing. Once the researcher or the data analyst define types of data for the collection, researcher, data analyst focuses on processing of data for decision. Data processing refers to filtering and clearing of raw data. Data processing make data suitable for further process of organizational decisions. Researchers or data analysis performs editing, coding, tabulation, classification, and make data clean in data processing process. Data processing makes editing of data sample and give a way to researcher for moving forward in the right direction of data entry. Then comes your coding of data. Coding of data refers to the process of transforming collected data or observations to a set of meaningful, cohesive categories. It is a process of summarizing and representing data in order to provide a systematic account of the recorded or observed phenomena. Coding is the analytical task of assigning codes to non-numerical data. The data that is obtained from surveys, experiment, or secondary source are in raw form. This data needs to be refined and organized to evaluate and draw conclusions. Data coding is a process of driving codes from the observed data. In research, the data is either obtained from observations, interviews, or from questionnaires. The purpose of data coding is to bring out the essence and meaning of the data that respondents have provided. The data coder extracts preliminary codes from the observed data. The preliminary codes are further filtered and refined to obtain more accurate, precise, and concise codes. Here we see how this coding example technically works. There's a keyboard, CPU, and monitor. As far as your keyboard, that means input will be providing coding numbers. It can be alphabet and signs to binary code. This travels in the form of data. It's come to the system memory, and now CPU works upon it. Then the output in the form of information comes in on the monitor, and that is decoding binary codes to number alphabets and assign various coding examples. What we have just discussed, it can be in the form of variable information. We have option and the code, how we perform. If we talk about the gender, it can be male or female. We can assign code 1 and 2. Age less than 25, 26 to 35, 36 to 45, and over 45. Four values can be assigned: 1, 2, 3, 4. And if we talk about in terms of the qualification, it can be higher secondary, diploma, undergraduate, postgraduate, and similarly we can assign four values to them. That means four codes. Data presentation for clearer reference. Data without a definite presentation will be burdensome. Presentation of data helps the researcher to make study meaningful. There are three methods of data presentation. Data presentation is an important aspect of research as it allows researchers to convey their findings effectively. It can be a textual presentation, tabular presentation, or graphical presentation. If we talk about tabular presentation, it can be a simple table or a complex table. And in terms of graphical, it can be quantitative or it can be qualitative. We will see it. Textual presentation is which involves presenting data in the form of written words, sentences, or paragraphs. This method is commonly used when the amount of data is small and when the researcher wants to highlight specific details or findings. Another one is tabular presentation. This method involves organizing data in a table with each row representing a case or observation and each column representing a variable. Tabular presentation is useful when dealing with large amount of data and it allows the researcher to compare and contrast different variables easily. Then comes your graphical presentation. This method involves presenting data in the form of graphs or charts. Graphical presentation is useful when the researcher wants to show patterns, trends, or relationship between variables. Graphical presentation can make it easier for readers to understand and interpret the data, especially when dealing with complex data sets. Common example of graphs what we use: bar graph, line graph, scatter plots, pie charts, etc. To avoid the complexity involved in the textual way of data presentation, people use tables and charts to present data. In this method, data is presented in rows and columns, just like you see in a cricket match showing who made how many runs. Each row and column have an attribute: name, year, sex, age, and other things like these, depending upon the information what we have gathered. Graphical presentation has been divided into further categories. Column chart. A column chart is a type of chart that is commonly used to display data that is arranged in columns or rows on a worksheet. In a column chart, categories are typically displayed along the horizontal, that is category axis, while the values are displayed along the vertical value axis. Each column in the chart represents a different category, and the height of each column represents the value associated with that category. Column charts are useful for displaying data that can be divided into discrete categories, such as sales by the month or the number of students in different grade levels. There are also effective of showing changes in data over time, such as changes in revenue from year to year. Column charts can be easily customized to display different colors, labels, and formatting options, making them a flexible and versatile tool for data visualization. Then comes your histogram. Here, the group frequency is written in on the x-axis and the number of students are marked on y-axis, that's the vertical axis. The data is represented in the form of bars. A histogram is a graphical representation of frequency distribution. It consists of series of vertical bars or bins that represents the frequency of occurrence of a range of values. The width of the bar is determined by the range of values being analyzed, and the height of each bar represents the frequency of occurrence value within that range. Histograms are commonly used to analyze the shape of the distribution, identify outliers or unusual values, and determine whether the data is skewed or normally distributed. Histograms are a useful tool for exploring and visualizing data and can provide valuable insights into the underlying pattern and trends within a distribution. Frequency polygon. When we join the midpoint of the upper side of the rectangles in a histogram, we get a frequency polygon, as we can see over here. Then comes your line chart. Line chart is another type of chart commonly used to display data that is arranged in columns or rows on a worksheet. In a line chart, the horizontal axis represents evenly spaced categories such as time, periods, and the vertical axis represents the values. Line charts are useful for displaying trends in data over time or for comparing multiple sets of data. They are effective at showing changes in data over time, as well as identifying patterns or cycles in the data. Line charts can be easily customized with colors, labels, and other formatting options to enhance their visual impact. Then comes pie chart. The pie chart is a type of chart that is commonly used to display data that is arranged in one column or row on a worksheet. In pie chart, the data points are represented as slice of a circle, or we can see a quarter, which each slice representing a portion of the whole. The size of each slice is proportional to the value of the data point it represents, and the total size of the pie chart represents the sum of all the values in the data series. Then comes your tough nut chart. A tough nut chart is similar to a pie chart in that it also shows the relationship of parts to a whole, but it can contain more than one data series. In a tough nut chart, data points are represented as slice of a tough nut shaped circle, with each slice representing a proportion of the whole. The size of each slice is proportional to the value of the data point it represents, and the total size of the tough nut chart represents the sum of the values in the data series. Tough nut charts are useful for displaying data that can be divided into categories or parts and can be effective at showing the relative size of different categories or parts. They are also useful for comparing multiple data series, with each represented by a different definite slice. Definite charts can be easily customized with colors, labels, and other formatting options to enhance their visual impact. Bar chart It is another type of representation of the information. A bar chart is a type of chart which is commonly used to display data that is arranged in columns or rows on a worksheet. In a bar chart, categories are displayed along the horizontal category axis, while values are displayed along the vertical axis, that is the value axis. Bar charts are useful for illustrating comparisons among individual items, such as sales by product or revenue by department. They are also effective at showing changes in data over time, such as change in market share from year to year. Then comes your area chart. An area chart is a type of chart commonly used to display data that is arranged in columns or rows on a worksheet. In an area chart, the data is plotted as a series of points, which are then connected by a line. The area between the line and the horizontal axis is then filled with color, creating shaded regions that shows the trends in the data. Area charts are useful for plotting changes over time and for drawing attention to the total values across a trend. By showing the sum of the plotted values, the area chart also shows the relationship of the part as a whole. Area charts can be easily customized with color, labels, and other formatting options to enhance their visual impact. Then comes your bubble chart. Bubble charts are useful for displaying data that has three dimensions such as sales, revenue, profit, market share for different products. They can be effective at showing patterns or relationship among different sets of data points, and they can be customized with color, label, and other formatting options to enhance their visual impact. Then comes your radar chart. A radar chart, also known as spider chart or a web chart, is a type of chart that is used to compare aggregate values of several data series. In a radar chart, each data series is plotted as a line or a shape that connects a set of data points arranged in a circular pattern around a certain central point. Radar charts are useful for displaying data that has multiple variables and for showing the relative strengths or weaknesses of different data series. They can be effective at highlighting patterns or relationship among the data, and they can be customized with colors, labels, and other formatting options to enhance their visual impact. Then comes your box and whisker plot. A box and whisker plot, which is also known as box plot, is a graphical representation of data set that shows the distribution of the data into quartiles, highlighting the median, that is the middle value, and outliers. The box in the plot represents the interquartile range, which is IQR, which is the range between the first quartile, that is Q1, and the third quartile, that is Q3. The median is represented by a line inside the box. The whiskers is the plot extended vertically from top and bottom of the box, indicating the range of values that lie within 1.5 times the IQ, above the third quadrant and below the first quadrant. Any point outside those whiskers is considered as an outlier. Box and whisker plots are useful for comparing multiple data sets as they allow you to quickly compare the medians, range, and variability of the data. Box and whisker plots are a valuable tool for data analysis and visualization, particularly when comparing multiple data sets. Then comes your funnel chart. Funnel chart are a type of charts used to represent values across multiple stages in a process, such as sales or marketing funnel. The bar in a funnel chart are arranged in decreasing order, with the first bar being the largest and the subsequent bars becoming progressively smaller. This creates a funnel-like shape with the largest section at the top and the smaller section at the bottom. Similar something like this. We have different layers. We have 7 layers and the different percentages of the observations are given. And according to the percentage, they have been drawn or plotted. Funnel chart do not necessarily have a tip to decrease gradually. The bars can decrease in size in a stepped or irregular pattern depending on the specific data being represented. Funnel charts are used full for identifying areas of a process where there may be drop-offs or bottlenecks, as well as for highlighting which stages are the important or impactful. Funnel charts are a valuable tool for visualizing data across multiple stages in a process and can help identifying areas where improvement or changes may be needed. Now, we move to Unit 8, that is Structured Query Language. We will be using this term SQL. It is a widely used query language for relational database management system, that is RDBMS. It allows user to manipulate and retrieve data from databases using various operations such as select, insert, update, and delete. SQL provides a user-friendly interface for querying databases and retrieving data in a structured and organized way. It also can be used for creating and modifying databases, structures such as tables, indexes, and constraints. SQL has some limitations. It is not as powerful as a universal Turing machine and cannot perform all types of computation that a general purpose programming language can. SQL also lacks some features such as user input, output, and network communication, which are typically provided by most programming languages such as C, C++, and or Java. SQL is a programming language that is widely used for managing and manipulating data in relational databases. It allows users to interact and with databases to perform a wide range of tasks, including querying and retrieving data, adding, modifying, and deleting data, and managing database structures and their relationships. One of the main advantages of SQL is its simplicity and user friendliness. The language is relatively easy to learn and understand, and its syntax is straightforward and consistent across different databases platforms. This makes it a popular choice for both beginners and experienced users alike. Another advantage of SQL is its scalability and flexibility. SQL-based databases can handle large volumes of data and are capable of handling complex queries and transactions. We can see what the different types of SQL commands are. DDL is data definition language. DML, that is manipulation language. TCL, that is data control language. TCL, that is transaction control language. And TQL is data query language. We will see one by one what does these all terms mean. IBM developed the original version of SQL as a part of System R project in the early 70s. The language was initially called SQL, but it names was later changed to SQL. SQL has become the standard language for managing relational databases, and it is widely supported by various database systems and products. In 1986, the NSI and ISO published the first SQL standard, calling it as SQL 86. This standard established a common set of syntax and semantics for SQL, ensuring that SQL implementation from different vendors could interoperate with each other. New versions of the standard have been released, including SQL 2003, 6, 8 till 16. SQL standardization process is a critical aspect of the language's development and evaluation. It helps to ensure that SQL remains a stable and reliable language for managing relational databases, and SQL implementation from different vendors are interoperable and can work together seamlessly. The SQL standardization process is overseen by the International Organization for Standardization, that is ISO, and the American National Standards Institute, that is ANSI. These organizations establish and maintain a set of standards for SQL that specify syntax, semantics, and functionality of the language. SQL standardization is a collaborative effort involving database, vendors, developers, and other stakeholders in the industry. The process involves processing and reviewing changes to the SQL standard and ensuring that these changes are implemented consistently across different databases platforms. Once, one of the main benefit of SQL standardization is that it helps to promote consistency and compatibility across the different database platforms. SQL standardization process is an essential aspect of the language development and evaluation and helps to ensure its continual relevance and usefulness in managing and analyzing data in relational databases. Data definition language, that is DDL. The SQL data definition language provides commands for defining and managing the schema object in a relational database. The schema object includes table, indexes, views, sequences, and other database objects. The SQL DDL provides a set of commands for defining and managing the schema objects in a relational database. Some of the commands what we use in SQL, for if we use a command create, it is used to create new schema objects such as tables, views, indexes, and sequences. Alter, as the name suggests, it is used to modify the structure of existing schema objects, such as adding or dropping columns from a table, or modifying the definition of an index. Drop, it is to delete an existing schema object, such as table or view. Truncate, it is to delete all the row from a table while keeping its structure intact. Rename, to rename an existing schema object such as table or a view. In addition to these DDL commands, there are other commands that are used for managing the security and integrity of the database, such as granting and revoking privilege, setting constraints, and defining triggers. When a DDL command is executed, any changes made to the database schema are automatically committed and become permanent. This means that DDL commands are typically used with caution as they can have a significant impact on the structure and content of the database. SQL language provides three main categories of command: data definition language, that is DDL, data manipulation language, that is DML, and data control language, that is DCL. DDL commands are used for defining and managing the schema object in a relational database. In contrast, DML commands are used for manipulating the data stored in the database. Some of the DML commands are: select. It is used to retrieve data from one or more tables in the database. Insert. It is to add new rows of data to a table in the database. Update. To modify existing rows or data in the table. Delete. It is to remove the rows of data from the table in the database. Then comes your data control language. DCL commands are used for controlling access to the database objects. These are two commands: grant, which is used to give specific privilege to a user or group of users in a database object. Second one is revoke. It is used to remove specific privileges from a user or a group of the user on a database object. DML, DDL, and DCL commands together provides a comprehensive set of tools for managing and administrating relational databases. Database administrators and developers use these commands to create and modify database objects, manipulate data stored in the database, and control access to the database objects to maintain the integrity and security of the data. That is the most important part. SQL DDL also allows specification of not only a set of relations but also information about each relation. The schema of for each relation. The schema for each relation is a relational database which defines the structure of the data that is stored in the table. This specifies the names of the column or attributes, the data type of each column, and any constraint or rules that governs the data in the table. We consider a simple relation database that stores information about the employees. The schema of the employees table might include the following columns. That is employee ID, which is a unique identifier for each employee, which will be a data type in integer. First name, the employee's first name. Here the data type will be a string. Last name, the employee's last name. Again, it will be in the form of string. Date of birth. It is the employee's date of birth. Here the data type will be in the date. And date format is here, month, date. Or it can be date, month, year. Department ID to which the employee belongs. The ID of the department of the employee in which it works. Here the data type will be in integer. The schema of each relation is an important component of the database design process. It provides a blueprint for the database that guides the development of the database structure and the creation of tables and columns. It also helps us to ensure that the data in the database is accurate, consistent, and well organized. The domain of the values associated with each attribute in a relational database defines the set of allowable values that can be stored in an attribute. The domain of values for each attribute is an important consideration in database design, which helps to ensure that the data stored in the database is accurate and consistent. By limiting the range of allowable values for an attribute, the domain helps prevent data errors and ensures that the data is of consistent type and format. In addition to specifying the domain of values for each attribute, The database designer may also define constraints or rules that further restricts the allowable values for an attribute. Then comes your integrating constraints. Integrity constraints are rules that are used to ensure the accuracy, consistency, and the validity of the data stored in a relational database. These constraints help to maintain the integrity of the data by preventing the insertion of invalid or inconsistent data into the database. There are several types of integrity constraints, such as primary key constraint, foreign key constraint, unique constraint, check constraint, not null constraints. And they all have their individual meaning. Set of indices to be manipulated for each relation. Indexes are data structures that are used to speed up the retrieval of data from the database. They work by creating a copy of a subset of the data in a table and organizing it in a way that makes it easier to search for specific values. The set of indices to be maintained for each relation will depend on the queries that are commonly run against the table. Commonly, common types of indexes includes primary key index, unique index, clustered index, and non-clustered index. The security and authorization information for each relation. It is again an important consideration in the database design. This involves determining who has the access to the data in relation and what type of access they have. Common security and authorization measures that can be implemented in a relational database includes user authentication, access control, data encryption, auditing, and backup and recovery. The physical storage structure of each relation on the disk. It is also an important consideration in database design, as it involves deciding how data is stored in the physical storage media, such as hard disk or solid state drives. There are several factors that can influence the choice of physical storage structure for a relation, which includes access pattern, storage medium, size of relation, and security requirements, if any. Common physical storage structures for relational includes heap file organization. This is the simplest storage structure where data is stored in an unordered list. It is useful for making small relations or for append only workloads. Second one is sorted file organization. Here, the data is stored in a sorted order according to a particular attribute, that is the requirement, and it is useful for range queries and joins. Then comes your hash-based file organization. Here, the data is organized using a hash function which allows for efficient lookup of individual records. It is useful for equality-based queries. Fourth one is B-tree file organization. Here, the structure organizes data in a tree-like structure, allowing for efficient range queries and updates. SQL standard supports a variety of built-in domain or data types, including char, a fixed length character, string with user specified length, and the full form character can be used as text. Then comes virtual, again denoted by n, a variable length character string with user specified maximum length of n. The full form character varying is equivalent. Third one is int, that is for integer. An integer at finite subset of the integer, that is machine dependent. The full form integer is equivalent. Small int. A small int is small integer. Numeric PD. A fixed point number with user specified precision. The number consists of p digits plus a sign, or and a d of the p digits are to the right of the decimal point. Real double precision. Floating point and double precision floating points. Numbers with machine dependent precision. Float. A floating point number with precision of at least n digits. And date. A calendar date, 4 digit, year, month, day of the month. Interactive data manipulation language, that is DML. DML is a language that enables users to access or manipulate data as organized by the appropriate data model. They are basically of two types. First one is procedural DML, which requires a user to specify what data are needed and how to get those data. And the second one is declarative DML, which refers to the non-procedural DMLs, which requires a user to specify what data are needed without specifying how to get those data. Data manipulation is the retrieval of information stored in the database, the insertion of new information into the database, the deletion of information about the database, and the modification of information stored in the database. This is what is meant by data manipulation. A query is a statement requesting the retrieval of the information. The portion of the DML that involves information retrieval is called a query language. Although technically incorrect, it is a common practice to use the term query language and data manipulation language synonymously. Now comes your view definition. A view is like a window through which data from tables can be viewed or changed. The table on which a view is based is called base table. The view is stored as a select statement in the data dictionary. When the user wants to retrieve data using view, following steps are to be followed. First one, view definition is retrieved from the data dictionary table. For example, the view definitions in Oracle are to be retrieved from table name user views. Second one is checks access privilege for the view based table. And the third one is convert the view query into an equivalent operation on the underlying base table. What are the advantages of it? It restricts data access. It makes complex queries look easy. It allows data interdependence, and it presents different views of the same data. What is transaction control? SQL provides commands for managing transactions in a relational database. A transaction is a sequence of SQL statements that are treated as a single unit of work. Transaction can include both read and write operations on the database. SQL specifies that a transaction begins implicitly when an SQL statement is executed. The transaction remains active until it is explicitly ended with a command or rollback statement. The commit statements makes the updates performed by the transaction becomes permanent in the database. Once the transaction is committed, a new transaction starts automatically. In addition to commit, SQL also provides the rollback statement for ending a transaction and undoing any changes made during the transaction. Rollback work, it is because it causes the current transaction to be rolled back. That is, it undoes all the updates performed by the SQL statement in the transaction. Thus, the database state is restored to what it was before the first statement of the transaction was executed. Once a transaction has been executed, commit work has been done. Its effects can no longer be undone by rollback work. We move to Unit 9, that is DBMS implementation and future trends. With the advent of cloud computing, the market of database management system has shifted towards cloud-based solutions. Cloud-based DBMS solutions offers many advantages over on-premises solutions such as scalability, flexibility, and reduced infrastructure cost. Cloud-based solutions also offers the ability to easily integrate with other cloud-based services such as analytics and machine learning tools, which can help organizations gain insight from their data more quickly and efficiently. Another advantage of cloud-based DBMS solutions is that they often come with built-in security features such as encryption and multi-factor authentication, which can help to protect sensitive data. Despite the advantages of cloud-based DBMS solution, there are still some organizations that prefer to use on-premises solution due to concerns about data security, compliance, and control. In response to this, many DBMS vendors are now offering hybrid solutions which combine on-premises and cloud-based solutions to provide organizations with the best of both worlds. It depends upon the organization which way they go. Legacy system can pose several challenges for organizations such as security, vulnerabilities, difficulty integrating with newer technology, and the cost of maintaining outdated hardware and software. Despite these challenges, many organizations continue to use legacy systems due to their business critical nature, cost effectiveness, or simply because they work well and there is no pressing need to change them. The challenges posed by legacy systems. Here, organizations can take variety of approaches such as modernization, migration, or retirement. Modernization involves updating the software or hardware components of a legacy system to improve their functionality and maintainability. If we talk in terms of migration, it involves moving data and application from its legacy system to a new one. And the third one, that is the retirement, which involves decommissioning a legacy system and transitioning to a new one altogether. DBMS are changing. However, they are expanding, taking on more responsibilities and providing smarter answers. As new goals and problems present themselves, the desire to find new ways to use database management system prompt unique solutions. Standards are very important for application development, especially in the age of the internet, since applications need to communicate with each other to perform useful tasks. A variety of standards have been proposed that affect database application development. Electronic commerce is becoming an integral part of how we purchase goods and services, and database plays an important role in that domain. Web interfaces to database. The web has become important as a front end to databases for several reasons. applications, such as web browsers provide a universal front end to information supplied by backends located anywhere in the world. The front end can run on any computer system, and there is no need for a user to download any specific purpose software to access information. Today, almost everyone has an effort in its access to the web. With the growth of information services and electronic commerce on the web, database used for information services, decision support, and transaction processes must be linked with the web. Web interfaces or databases allows users to interact with and manipulate data stored in a database through a web browser. Some common types of web interfaces to databases are web forms. These web forms allows user to input data into a database through a web browser. They can be used for tasks such as data entry, surveys, or online orders. Second one is reporting interfaces. Reporting interfaces allows users to query and retrieve data from a database and displays the result in a user-friendly format, such as chart, graphs, or tables. Then comes your dashboard interfaces. Dashboard interfaces provides an overview of data in a database, often using visualization such as charts and graphs to display key matrices and trends. With this, we will be stopping over here, and in our next session, we will start further. Okay, ये दो बार